Okay. So we're talking about prime factorization today. We talked about prime numbers yesterday. I'm going to have to write with my finger today, so it's going to look a little funky on me. See, I can do this, but I can't do that. Hey, that video's on. Let's make sure that we're being quiet so I can be loud. Prime factorization. Okay, so we have our notes. Here is the deal. Let's just jump right in. Right? Prime factorization is the writing of a composite number as a product of all its prime. Exactly. Right with my finger today, so y'all just got the deep. Game show host, exactly. Is that what you're gonna say, Landon? Is that what you're gonna say? I don't want to be a YouTuber. I'm just getting close to lessons. I look like a YouTuber?
Yeah.
What, I'm like a little handsome man who has funny ideas?
Yes.
Yeah, I'll take that compliment. Alright. We're going to use what's called a factor tree to write the prime factorization of 42. Okay? So factor trees. You may recognize this once we start. Okay? So the first thing is what we want to do is we want to write the product. We want to write this number as a product of two factors. So what two numbers will go into 42? 6 and 7. Okay? And then we want to circle any prime numbers. Do you see any prime numbers? 7 is a prime number. Okay. And then once we no longer have any composite numbers, we want to write all the factors from least to greatest. Now, do we have any composite numbers?
Yes.
We do. So 6 becomes 3, 2. And we want to circle them. The second we notice that it's a prime number, we want to circle it. And now we want to write all the prime factors from least to greatest. It's important that we write it from least to greatest, right? Otherwise, it's not prime factorization. So our answer for this problem would be 2 times 3 times 7. I just follow you. Yeah. And that is our answer. Thanks.
Here, I got something for you.
Is there a tripod for my iPad? I'm filming right now.
It's some common sense.
Go slower.
There's the same thing on their version.
Well, I tried to put it up here. The problem is when I put it close, I can't get me and screen. I don't need to get I may edit it out. I know. I didn't lock it in place when I was sliding it to get it right. And it fell down. I was going too fast. Yeah, I was going too fast.
Gotta be more careful.
I put it all the way up, but I guess I didn't put it all the way up. So it fell with enough pressure. Oh my God, your shoes. It's really, really sharp. All right, ladies and gentlemen, we have 5 of these here. We're done. Thank you. Okay, 100 milligrams split up into what?
25.
Why are you going to split up into 50-50? You can't multiply 50 times 50 to get 100.
50 times 2.
Seriously, you guys getting 50 and 2?
Oh, 10 times 10.
Can we please do 10 and 10, please?
I can't put it on the time.
Addition.
Now, are either of those prime?
No.
So we keep going. To get 10 is 2 and 5. 2 and 5. And those are all prime. So now when we write this out, we want to write any repeated prime factors using exponents. So the way we would do that is, so this is 2 by 2 by 5 by 5. And that is not our answer. This is not fully simplified into our primes. Man, that's a bad equals sign. Stop it. I'm not good with my fingers. Okay? So we want to, excuse me, we want to write any repeated prime factors using exponents. So we talked on the quick plot today, right, about what those look like. So what's 2 by 2 going to be represented as? 2 squared. 2 squared, exactly. 2 squared. I'm trying to write the square, but my finger's not working. There we go. And then the 5 squared is going to be, or the 5 by 5 is going to be 5 squared. And that is, in fact, our final answer. Okay? Questions on that? That's prime factorization.
I did 50 times instead of 10 times.
And you get the same thing?
Yeah.
Exactly. So what we're seeing is that it doesn't matter which factor pairs we use, Landon. You need to keep the animal noises out of the classroom. It doesn't matter which factor pairs you use. Okay? If Ashley used 50 and 2. Circle 2 and then split 50 into what? 5 and 10, and then split it again. So if you come up with any factor pairs, the cool thing is this method will get it to be able to write like this. Now, people are always like, why do we have to do this? Well, one, it's a state standard. And two, when we talk about square roots, it's going to help us to know how to do this. So when we talk about square roots later on, it's going to help us to know how to rewrite a number as this prime factorization. Okay? So you have 3 more examples that we're going to do. Well, that's really annoying that it's doing that. I want you to do those with your partner. Work your way all the way down. And you can check yours with mine as you go. There should be plenty of room underneath of your notes to write these down, or just, underneath right there. Notice the divisibility rules will help you get factors, won't they? It's 130. What should instantly come to your mind? 10. Exactly. So keep that in mind. Your divisibility rules will help. You can skip a couple minutes in the video until we're done with these.
No, because 2 times 40. So it has to be 30. Yeah. Wait, what? Yeah, 2. No, that equals 6. Sorry.
You should be done before I am. Okay? Be done with these next problems before I am. Okay? So you and your partner are working through these 3 problems using the method that I've shown you.
Yeah.
I knew they did that. 13.
Go. Good. So 3 goes into and 2 goes into.
And then maybe you'll see a familiar number. It'll take longer, but it's there.
Go ahead, Daddy. Let's hear your conversation. Talk it out. All right, let's check what we got. Now, notice, I'll be honest with you, on the middle one, how did I know that 3 went into it?
Because you asked for it.
7 plus 8 is 15, and 15 is by 3. So I went ahead and did it by 3 in my head. If you were unsure, what else could you do as your factors for 78? What do you recognize about this number? Steven? 39 and 2, because it's even. So if you're ever unsure, look at it. If it's even, what should you do? If you're ever unsure of bigger numbers that go into it, if it's even, you know that 2 will work. For instance, on 126, yeah, 3 goes into it. Does 9 go into it? Absolutely, because 1 plus 2 is 3, plus 6 is 9, and 9 goes into 9. So 3 goes into it, 9 goes into it, 2 goes into it because it's even. I went ahead and divided it by 2 first because it was easier for me to see. Then 63, I was like, oh, hey, I recognize that one. 63 is 9 times 7. Awesome. So then I split that up. Notice, this is an intermediate step. This is the final answer. It must be put in what I call ascending order. Everybody say ascending. Ascending order means what? Up. Ascending. If you ascend the staircase, does that mean you go up the stairs, down the stairs? It means you're walking up the stairs. Ascending order means from least to greatest. So this is an ascending order. Okay? Yes?
I did 9 times.
Right from the beginning? Okay. Did you get the same structure? Then I think you found out, I think what Ashley has discovered is that it doesn't matter which factor pairs you use, as long as you factor all the way until you get to what? Until you get to what, Sandra? Prime numbers. So you get to prime numbers. It doesn't matter which factor pairs you use as long as you factor all the way to the primes. Because what's this called?
Prime factorization.
Prime factorization. So every answer, every number in these answers should be what?
Prime.
That's the whole point. And if you're ever unsure if you factored it correctly, take out a calculator. If you're ever unsure, check your answer. Use a calculator. 2 times 3 squared times 7. And what should I get? Should you get 126? And I do. Okay. All right. Homework today is a prime factorization worksheet. That's 26. And con 2 Wednesday. Okay, you don't have to ask Class, put it down. Alright, so on this prime factorization worksheet, numbers 1 through 12, you must show your factor trees. Alright? Number 1 through 12, you must show your factor trees, you must show work.